Hi, everybody. Welcome to today's in Italian informational. Thank you so much for coming. Today we have with us Nishant, who's going to be talking a bit about coding hygiene. So here's just a bit about Nishant. Nishant's a software engineer who currently works at Google. He's worked with multiple teams during his time on the engineering productivity team since 2018. His exposure to different teams and their individual coding styles has helped him understand better the necessities of code style and hygiene. As part of the engineering productivity team, he's also worked heavily with visualization and analysis. Before Google, he interned at Beta, where he helped in developing a revamped version of their application using React.js. Outside of work, he's involved in Toastmasters, an international speaking organization. He's helped organize multiple programs with 100 to 300 attendees. When he's not helping out at Toastmasters, he loves cooking and reading. With that, I'll hand it over to Nishant.
Hey, everyone. It's not enough for code to work. Robert C. Martin. Robert C. Martin was an American software engineer and an instructor. He was one of the authors of Agile Manifesto and also wrote the book, Clean Code, a handbook of agile software craftsmanship. What is code hygiene? Does anyone know or can give me a one-liner or at least answer why is it not enough for code to just work?
I guess it has to be neat and concise. So if someone else reads the code, they'll be able to figure out if there's an error or when you debug stuff.
Yeah, that's pretty much it. Hygiene, code hygiene. The hygiene definition itself is conditions or practices conducive to maintaining health and preventing diseases. The diseases for programmers are bugs. And I'm sure a majority of you faced some sort of bug or problem, and that's what we're trying to limit with code hygiene. And it's supposed to help with readability and making sure that there's a structure to the logic. Now, there are reasons why it's important. And one of the questions on why it's important, one of the reasons why it's important is to avoid code like this. You can see that there's just lines and lines of code. Does anyone here see a comment? If anything, there's one comment in there that's commenting a line out, but no. When you're practicing best practices for programming and you're practicing code hygiene, it still makes sure that you don't come back to code like this and get really confused. I've done this multiple times. I've coded my whole CS 150, I think it was ECS 60 code, a project back in UC Davis, finished the whole thing, and then realized there's a bug, went back, and I had no idea what I had written. It made sense when I was writing it, but I had no idea what I'd written. There was no flow, there was no clarity, there was no structure. It was a definition of bad code. My main function itself was 100 lines long, and because we had to have classes, I had two files for classes. That is why, so because you don't want to get into my kind of situation, that is why you practice code hygiene, and that is why you follow some best practices. I'll be talking about a couple best practices as well as what falls under code hygiene during this session. And one thing that you guys need to know is it definitely gets you grades. Because if the grader can read what you've written, if the flow is easy, if the code is self-explanatory, man, there is no need for you to get docked 2 points for the comment section of the grade, nor the style section of the grade. That might be something that you've already faced. I personally did when I was doing my programming courses. And better practices in how you code, so best practices in how you code also make you a better programmer over time. Why are senior programmers senior programmers? There's a reason why. Because they look at, not necessarily code hygiene, but they look at the design of things. And we'll talk about that in a bit. So what falls under code hygiene? What are some things to look out for in terms of code hygiene? There are a couple things, couple simple things that you've maybe experienced, you've done yourself, that were required of you, but
just making sure that everything's clear, but I mean, that's kind of the definition of it.
Mm-hmm. Yeah, so file, like kind of a structure to it, right? That's how you keep things clear. That's one thing you can use to keep things clear, right?
You briefly touched on this, but like comments throughout the code so people know what like is going on.
Mm-hmm. Comments, yep. And there are two types of comments. We'll be talking about that as well.
I think it was brought up earlier, but just like being concise and just making sure that your program runs efficiently.
Okay. While efficiency is definitely important to a program, code hygiene primarily focuses on the readability and the flow. It's not necessarily how fast it can execute, and that's a different topic altogether. So yes, definitely the fact that it should be readable, and that's where nomenclature comes into play. And that's definitely something we'll be talking about.
Yeah, so I think like I also study like take some computer science classes, and what's come back to really bite me, like you mentioned, you have a bug and you go look at your code and it's foreign to you. I think indentation is a big part of it, at least in my experiences. That's really been the difference in readable code versus garbage.
Yep, indentation is definitely one thing. Formatting, having kind of a style to this, it's very important to code hygiene. And there are a couple more stuff, and we'll talk about that briefly, if anything. Like it was mentioned, comments. Comments are a big thing. I'm sure that your professors have said, comment your code. There are two types of comments. There's a single line comment and there's multi-line comments. For single line, you want to make sure it's short and it's meaningful. You don't want to have a really long run-on sentence that explains what your code does. You want to have a full statement, a complete sentence of what exactly is happening. And make sure that each of your comments end with a period. That's how you're making sure that the line is a complete sentence and it's simple and to the point. Another thing is you should have multi-line comments for classes, functions, and files. I'm sure that any one of you have heard of most of you have heard about the example of having a vehicle class and then a car class and then maybe a motorcycle class. Yeah, that is self-explanatory, but what does a vehicle class do? What is it supposed to contain? What is it supposed to do? What is a car class supposed to do? Why is it different from the vehicle class? What is a motorcycle class supposed to talk about? Why is it different? Each class has something unique to itself, and that's where the multi-line comments come into play. Having these comments will make it easier for you to also figure out, and your partner, if you're ever working with a group, you're a team, just a single partner, or even your professor, someone you hand your code off to work with or share your code with, it'll make sure that it's easy for them to catch on and read. And one thing you want to make sure that you do is minimize your comments. I know I'm being very contradictory here. Yes, having comments is good, but you want to reduce your comments. Have meaningful code. You only have to write comments when the code is bad, in terms of it's really complex, you can't understand it, or there's a lot going on. You really have to have a comment to explain what's happening. And you really shouldn't have to use comments otherwise. Code should be self-explanatory, like I mentioned. And comments are important not just for clarifying things, but it helps reviewing quick. This is where comments come into play, and I've done this multiple times. I learned from one of my interviews where they asked me about my project, and I had been like, yeah, I did this about 2 months ago. I can easily remember everything they asked me. I went into the interview, had no idea what my project was about, except for the fact that it did this, which was, oh, it's a visualization project which maps different databases to each other and make sure there's connections and helps you figure out which database has which research. Cool. So can you explain what exactly happens in the front-end part of the code? Yeah, it uses D3. That's where my conversation ended. You don't want to be in that situation. By having comments, you can go back and easily just skim through the comments. If the line, and we'll talk about this next, nomenclature, if the functions are easy to read, if the variables are easy to read, then it's a lot more easier to understand what exactly happened in your code. And It becomes a quick task rather than you trying to relearn your code after 2 months of writing it. And last is, if you are going back to edit some code, make sure you update that comment if the comment is not relatable anymore. If it's not, if the function of the block of code or changes, then you want to update the comment so it still makes sense and it's still relatable to that section. Now, nomenclature. Nomenclature is very important. This is where you want to make sure that your variable names, your function names, your class names, any kind of names that you use reveal your intention. They should have meaningful names. And you want to avoid extraneous words such as variable, string, integer. You don't want to have dashboard string. It means nothing. You already know it's going to be a string from how you use it and how you establish it. For example, in Java, you're going to say string dashboard string. You've already mentioned it's a string. You don't have to say it's a string again. In Python, you might say var dashboard, but the fact that it's initialized to a string would be self-explanatory. There's no need to go back and have string integer in the name. And when I say meaningful names, this also means it has to be pronounceable. The variable name that I have up there, I'm going to understand. I am going to understand. It means product delete count. But for those of you who don't know, it's going to be prod DLT ECNT. It makes no sense. Whereas if I had written it as deleted product count, it makes it so much more clear on what exactly that's supposed to be. It's a counter variable. It's supposed to count deleted products. So while you're programming, make sure that every variable you create makes sense. That said, don't just be like, oh, Troy is a variable I'm going to use, but I need to use another variable that talks about Troy, so I'm going to call it a Troy or the Troy. No, it's just going to get confusing. So make it more meaningful by flushing it out. It's fine to have a slightly longer variable. As you can see, deleted product count is slightly longer than what you might be used to, but it still works for the function of making sure your code is readable and making sure that anyone else can read it, right? That said, don't spend so much time on figuring out what the name is. Keep it simple and straightforward. When you're finding names and you find it's really hard, one of the things that I've known programmers to do is they use IJK. Int I is equal to 0, I is less than j, and where j is equal to 7, and I plus plus. Yes, that's a typical counter. But what is the counter supposed to track? What is it supposed to do? That's where you should still like make it more meaningful. If the counter is supposed to count deleted products, you want to say deleted product int deleted product equal to 0. Deleted product is less than total number of products. Deleted products plus plus. That makes it more explanatory. Lastly, you want to have a convention. There should be a convention for your global variables, your class variables, your local variables. Yes, that's a lot. So minimum that you should do is have a convention for your global variables and local variables. I personally have capital letters with underscores for my global variables, and for my local variables, I do camel case. And depending on the language, I sometimes add in underscores and keep everything lowercase. That's how I keep it, and I make sure that for every one of my different projects that I do where the language changes, I keep that consistent, even if it's a personal project. So at the end of it all, you want to make sure that there's nothing, or the very little mental mapping that you do to figure out the meaning of the variables or the names, and keep it simple. Follow the KISS method. There's a reason why it's a commonly known design principle. It doesn't mean to KISS, it means to keep it simple, stupid. Now, structure is something that a lot of people tend to forget, and it's because they hate writing functions. But if you don't write functions, your code is just going to get that much more confusing. Create as many functions as necessary. And you can use functions where you're repeating code, you have unique behavior. Let's say there's a really complex part, a mathematical computation that you have to do that it doesn't make sense for it to be in the flow. Break it into a function. and call that function there. Say complex mathematical solution maybe. Of course, make it a lot more less generic and a lot more specialized, but that's something you can do. And also, if you have any kind of thing, any kind of portions of code that increase readability, put it into a function, call the function, and have the name over there. In one of my recent projects, I had so many functions because for each different device I was working with, they had similar but different code blocks or like a code body that I had to differentiate primarily because I was doing parallel programming. So for that, I created different functions which were meaningful. So when I was reading through my flow of the main code, it made so much more sense. It made so much more sense when I was going back and explaining to my coworker, hey, so you can see that first it does this, 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 and this is where it branches out. And that's what made it a lot more easier for me to even have a flow in explaining as well as reading. And make sure to comment your functions. Make sure that you have at params and at return. So when you look back, or even if you're just trying to skim through your code, you can immediately identify what the function does without having to read the body of the code. That's what comments are for. So again, don't forget about comments. Don't forget about nomenclature. Don't forget about structure. And lastly, don't forget about classes. I touched upon this, right? You might have a vehicle class, you might have a car class, a motorcycle class. That makes more sense than having just a vehicle class with a bunch of car class functions and motorcycle class functions in it. Primarily because when you have something broken into different classes, you can inherit common functions, you can write specified functions, you can overload them, override them, all the cool stuff that you learn in college that you kind of use once you start working. And you want to create classes for anything that has a different behavior. Like I mentioned, a car goes motorcycle goes vroom vroom, and a vehicle it doesn't have a specific sound because there's a bunch of different vehicles. And maybe that sound is something that you want to use. It's like, oh, analyze this particular sound for this object and update that as you go. I don't know. It's up to you guys. Now, formatting. This is where the logic flow really is important. I personally suggest having your global variables first, your setup functions for a second, and then any other like any other functions which rely on the setup functions third, and then you have your main code last. Your main code should launch all the functions. That's something I follow. So take your time to visualize and design the system. And once you've commented out the function saying, oh, this function does this, 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 it's supposed to accept at least 2-3 parameters, and then it's supposed to return this value. When you've figured out the logic, the flow, it becomes a lot more easier to code the actual body because you already know what's supposed to happen. And at the end of the day, the goal should be not just that it's readable, but you can read the code from top down the same way you scroll through the file, and you'll understand the code completely. You're basically doing the whole rocks and sand metaphor, where you put in the big rocks, you pour in the smaller rocks, then you pour in the sand, and then finally you pour in the water, and you've capped it out. You're building the foundation. And there are some languages with go-to. Disclaimer: avoid using go-to statements. They're going to make your logic that much more confusing. Yes, it's helpful. Yes, it's nice, but you're going to get confused. I definitely did get confused multiple times. Now, style. One thing that was mentioned in the question when I opened up to the floor is making sure we have indents. Block out your code and indent accordingly so that you can read the code easier. You can understand what's in scope, what's not in scope. Scope becomes very important when you initialize a variable inside, let's say, a for loop, and then you have to access it outside. If you don't indent your code or style your code such a way that it shows that, hey, this variable is not accessible outside the for loop, then you're going to have errors popping up when you run the file. Even though it'll look right, it won't be correct because when you come out of the loop, the variable is out of scope. So scope is something that scope issues you can definitely avoid by making sure you have your blocks and you have your indents. And also, when you break your code into meaningful blocks, you'll avoid big files by default. It's better to have 3 different files of 1,000 lines each, or than one file with 3,000 lines. You will see files with 3,000 lines, and when you're starting to work or you do your internship, it's a very possible situation, but they'll most likely have a bunch of functions also. That's why it's so long.
So Nishant, I actually had a question. So just, you've worked at or interned at Beta and worked at Google, and I'm sure you have a bunch of other experience. I was just wondering, do you have, is there like a universal set of rules? Because, sometimes you code in Java, sometimes you code in Python, and just different languages, different softwares. Is there like are these rules universal, or do they differ software to software, language to language?
So I think these are best practices in general. Having comments and multi-line comments, you're going to have comments available for every language. It might be the difference between a double slash and a pound symbol, like a hashtag, but you're still going to have comments. Nomenclature convention, that's something you can practice for any one of them. There isn't a specific style for each one of them. When you join your company, they will have a style generally saying, hey, variables for a local variable should be like this, class variable should be like this, global variable should be like this, class names should be written this way, function names should be written this way. But that's just to make sure that it looks smooth and it looks like the whole code base was written by like one person. So these are still things that are common. Things such as structure and formatting such as like tabs, indentation, blocks, that's more specific to the company itself. For example, some places don't even have blocks of code. They'll just be like, smash everything together. You don't want to have empty lines in between. And that's where it might get a bit confusing, but they might have also, oh, if you need to have a comment, add a line before so that it's a lot more clear what you're commenting. In terms of formatting, that's very company specific as well. They might have, depending on the language, for example, if you've worked with Java or C++, you'll have like templates and structs. Those are something that they might have outside. They might be like, oh, define a file separately and import it from there into your class and use it. For example, also maybe variables. If you have global variables that you're using across multiple files, they'll ask you to create a file separately for it, a class with all the, it's known as a variable class if I'm right, and you can pull in from there. And so in terms of formatting and structuring, that's the convention. It's a lot more, company specific, but in terms of commenting, while they might have a bit of style or guidelines for that stuff, generally you will have to, you should have comments and multi-line comments. Mm-hmm.
First, if there was a piece of code that isn't too complex and you could read it easily, would you need to implement code hygiene into that? And second, even if there's a complex piece of code, it has a lot of lines, it has a lot of different things to implement in there, but you could read it, or how to go through that code, would you need code hygiene for that? Is it very necessary? Because it takes a lot more time, right?
Yeah, so let me ask you a question in response. Were you the programmer? In that situation, would you be the programmer of that piece of code?
Yeah.
Would you have coded it?
Yeah, if I was, I coded it and I was able to read it also.
Okay, so that's kind of it. If you're the programmer, you might have a better understanding of your own code. Now, if the code is really simple and it's self-explanatory and it's a couple lines, then yeah, it's fine. You don't have to comment it. But if the code is complex and you know inherently that it is complex, then think about having another programmer coming in and being like, I need to read this. Do you think they would get it off on the bat? That's usually, if the answer is no, then that's when you would want to have the comments and break it up. If you, for example, let's say filter and maps. In response to your first question, actually, there's a slight caveat. Let's say I'm filtering some data that I've gotten and then I'm mapping it to do different things. While it might be like a 3-liner, it looks self-explanatory. It might be pretty complicated based on what I use for the mapping. If I use a lambda expression, they might not know what the lambda expression is doing. So I would have a comment saying, this does this, boom. And so that's what I'm saying. Like if it looks complex, if you have like expressions, lambda, mapping, or even mathematical calculations, usually it's a general idea. You can have the comments, and at most it's not going to hurt you. It's just a one-liner. It's really simple, really straightforward. And you know what the code is doing, so it won't take you that long. In terms of that complex, large piece of code, try to put comments. If it's like self-explanatory to the point where you don't think it's complex, it's readable, then it's fine. And a lot of this, you're just going to learn as you go in your career. As you write more code, you see more code, you hear people see presentations, you'll have a better understanding of when you have to add comments. So right now, just experiment, try it out. If you think it's complex, add it. If you don't think it's complex, maybe have someone else just take a quick glance at it saying, hey, do you understand this? If they say yes, move on. I hope that answers your question.
Okay, thank you. Yeah, it does.
Yeah.
Hey, Nishant, do you mind if I add a few thoughts on that?
Yeah, go for it.
Just a couple quick thoughts. There's the other aspect that two things. One is, let's say a year or 2 years from now, you want to come back and revisit the code for some reason and copy it in. So having commented it for yourself, you don't have to go relearn the logic of the code. And secondly, let's say you want to make additions or subtractions or modify the code, again, over some long period of time, it avoids the whole, why did I do it this way? What was I doing? So these quick comments can quickly, not only for yourself, but if you share the code with others, help them get situated. So I just wanted to add those two thoughts.
No, definitely. And this is kind of like pseudocode. Comments are, the single line comments are, they start off as pseudocode. I'm sure people, have you guys done pseudocode before? Yeah? Okay. A couple of you have, and I think that's very important. That's where you write out your code. You're like, hey, yeah, I'm supposed to do this, this, this. And then you evolve that pseudocode into comments. That way, it's not much work. You know what it's supposed to do. Before you start writing, you write it, you come back, clarify it a bit more for other people. That's basically it.
Yeah, so I was just wondering, this is a fairly short question, but you were mentioning how we use comments for the actual code aspect, but would you also do comments for field variables, or any variable pretty much telling what it's used for?
Yeah, I mean, global variables, if they're not self-explanatory or if you don't understand what they're used for, add a comment right there. There are also, if you end up having a class level variable variable class, then you don't want to go through each one, you can just toss in a file level description. That's not the best way to go about it. And like I said before with nomenclature, if it's not self-explanatory variable, then add a comment to it. It's complex, you don't understand it, so just add a comment there. And again, it's not that hard. The comment generally has to explain what it's used for or what it represents, right? That's generally how it works. Does that answer your question?
Yeah, thank you.
So there are other things that fall under code hygiene, and these weren't mentioned, but let's go over them. Unit test. There's a thing called test-driven documentation. You might not have comments. You might not have file level comments, class level comments, but if you have unit test, by doing test-driven documentation, you're basically giving a case of, okay, this is supposed to happen if I give this input, I'm supposed to expect this output. And that's going to be that's how you could define each piece of code. If you have 5 functions and you have tests for each function, a unit test for each function, you're basically saying, this is what the function is supposed to do. And that's the alternative to having file level comments. The reason why a lot of people don't do tests is that it's a lot more work. It's another language sometimes you have to learn, and it's just overall tedious because you have to debug. But if you have the time to goof off and learn this, and I'm saying learning this while you're goofing off, do it. Because it's that one thing that you're never gonna touch that you're gonna need later on. Because when you're a developer, there's different companies do different things. Sometimes they'll have an engineering productivity team or a QA team that'll write your test cases for you and then give it back to the developer. or they'll have the QA team own it. QA means quality assurance. But there are also other companies where the developer has to write the test and the code themselves. So if you have time, check out Google Test. It's an open source thing. Play around with it. Maybe write a couple functions, multiplication functions. Have one that multiplies, have one that squares, have one that, let's say, adds, and then test it. And again, even when you're writing unit tests, you want to make sure that unit tests are clear. You can you learn more about it, read more about it. Google Test is something simple. It's open source. There are so many other unit test platforms out there, frameworks out there that you can use. So try that out. Unit tests are one way to document as well and maintain code hygiene. Error checking. You might not do this and you will regret this. When you have huge projects, you're going to there's always a chance for errors to pop up. If you're able to identify, hey, there's a chance that this might give me a null pointer, or this might also give me, let's say, non-existent variable exception of some sort, then put an error checking. In Java, there's by default they'll always have a error checking. Even if you're maybe you guys have seen the try catch method. But try doing error checking. It makes it clear on what where you're expecting errors, and makes it a lot more easier to debug, because with error checking, whenever you catch the errors, you can also handle them right then and there. Let's say it's a common error that pops up every 15 runs of your code, and you know exactly what to do. For the sake of just making it work, you can handle it right then and there and have it continue. Another thing that you can do for code hygiene, and I highly suggest, is peer reviewing. This is where you can figure out if you did your commenting job right and if you made your code readable enough, because your peer reviewer will come back to you and say, I don't understand this. I think it'd be better phrased with this, or I think this is good to go. Yeah. They'll make sure your code is readable as you need it to be. They'll be your third-party readers. And lastly, the stuff that every programmer loves and hates, refactoring code. If it's a code that they really want to refactor, it's something new, they'll love it. If it's something they dread, they'll hate it. Self-explanatory. But a good programmer always refactors their code and makes it more clean. I highly recommend, if you, let's say you don't want to do your unit testing, you want to try something else, then maybe refactor some old code. I don't mean your Hello World program. I do not mean your Hello World program. I mean like the program you wrote for maybe a Java course, or even if you haven't done any program so far, do a small project. Maybe write a program for blackjack. Learn the rules, program the rules, figure out the cards, and then rewrite it. Yes, it's going to be tedious, but once you've done it already, you'll know what exactly the code's supposed to do. So just go back and rewrite it and see how much cleaner you can write it. And tackle it by function or file by file. That's up to you. But that's a challenge. So 2 challenges so far. Try unit testing and try refactoring any code that you have done, or if you haven't, write one and then redo it. Okay, so that's a lot of information. And yes, you're expected to know a couple of these, but I know you guys can't keep checking this all the time, okay? Linters are very important because they'll help you analyze the source code and figure out if there's any bugs, programming errors, or style issues. And they also help with security, styles, and static analysis. There's different types of linters for different programming languages and for different purposes. For example, you have static analysis. It checks for potential bugs, memory leaks, etc. You have your code convention. This is the styling part. Is it readable? Is it, does it decrease review time? Does it have indentation? Does it follow the nomenclature? All that stuff comes under the code convention. And also security. Some languages have them to detect potential security issues. There are some popular linters. You might have heard someone mention ESLint, JSLint for JavaScript, PyLint for Python. You might have also done Clang, I'll call it CLang tidy or CLang format for C++. So there are different ones for different languages. And if you are programming by yourself, or even for a high school project, a college project, a personal project, look into linters. This will save you time. This will help you identify bugs before they happen. And that way, all you have to do is type your code, put in your comments, make sure it looks good, run the linter. I forgot that semicolon. Catch the linter, catch the error, fix it, and then run it. Green screen, yay, except unless you have an error that you forgot to catch. This has happened multiple times. But linter does save your back multiple times, so I highly recommend doing a linter. Now, if you're adventurous and you really want to try and really want to learn the language, try out custom linter. It's going to be hard, but you'll definitely understand the grammar of the language overall. You know, how does Java work? What is the specifics? Everything. And if you don't know where to get started in terms of using linters, there are, like I said, popular linters. You can find editors that will work with these linters. For example, I know Adam has one. Sublime Code, I'm sure, also has one. I've used it in the past. And if you are really feeling programmer-esque, use Vim and find a command line linter that you can run on your files. Yeah, documentation, for me at least, I hate it. But it saves my back every single time, because if someone else wrote their piece of code, they had documentation, I can go and read it. If someone else designed a project, they had documentation, I can go read it. If someone else had FAQs for stuff that they faced, I can go read it, and it'll cut down my programming time. A good programmer spends time designing, like I mentioned at the beginning of the session. They also spend time reading documentation and understanding the overall aspect of their code or how a product works before they actually start working with it. Primarily, this will help you when you actually use it. You won't run into issues as often as other people who just dive in. While I understand that it's really easy to just get started programming, and you're like, yes, I'm the kind of person who just has the code and it's gonna figure it out. Take a step back. Take a step back and actually look at, take some time to design. Take some time to understand. And if there's documentation for a language or code or a product that you're using, go read it a bit. Get a general idea, and it becomes a lot more easier when you're coding. There are different ways to document. You can be documenting using Sphinx. These are third-party libraries that you guys can use off the bat. You can use Sphinx for like Python, C, C++. You can use Doxygen for C++, PHP, Java, Python. You can also use Java Docs for Java. Now, you might also, and most likely will, use LaTeX and Markdown. LaTeX I used in my college days primarily for my stats class when I was writing all these reports, for my EEC 172 class when I was doing a report on my lab, also for my mathematical technology related courses, and even my plain mathematical courses. We use LaTeX because it formats your answers and your report very cleanly and makes it easy to read functions, read equations, read solutions, read code, everything. And the same thing, Markdown also works. Markdown is more of a text to HTML tool for web writers, but it's also used for documentation. So let's say you're documenting a project on the grand scheme of things, then you can use Markdown to make it really nice and readable. The basic theme of our whole session today, readability. Readability will not only help you in the present, the future, but also it'll help everyone else when they look at your project. When you move from company to company, you will find a lot of code which is not documented, and you're gonna feel the pain. If you've looked at your partner's code and you've worked in a team, you'll understand how difficult it is. You already know how difficult it is to understand their code and be like, this is where the error is. And also, if when you're jumping from company to company, you'll leave behind code that you've worked on. You want to make sure that you're leaving behind code that is of good quality. So even when you talk about it in your internships or interviews, you can brag about it a bit. I'm not sure what bragging works, but bragging, brag about it, I would say, because it's a lot of people actually don't do documentation. It's kind of sad. Try starting early. do documentation early.
I have a question. You mentioned a lot of like codes, coding languages. So I was just wondering if there was like a specific language that you prefer, or like what language is, kind of more universally used in your field.
So as a data visualization, as a person who does primarily data visualization, I've worked with a couple different languages. It's kind of internal based, but I have used SQL for a lot of my analysis. I would create tables, I would analyze them, and then put them into readable things that then I would put on a dashboard or visualize. SQL, if you haven't had the chance, definitely look into it, because being able to interact with a database is very important. And you might not have to use it for high school or for college, but you'll definitely use some kind of SQL. It'll be nice to have at least that knowledge when you're working, because that way you can actually query and automatically just call a couple functions and then analyze it. I've also worked with Java. I did Java for a couple projects in college. And when I came into my line of work, there were times where I had to write tests, and I mainly wrote them in Java. There's also times where I've used Python. Python helps, especially when you're doing data visualization. I also used it for standalone files. Basically, when you start working, there's going to be a lot of languages you work with, and it really depends on the need. It depends on what the project is. Sometimes if you're doing backend work, you might end up using PHP. You might end up using something older than PHP, usually not, but you also might end up using Java or Python. You don't know. But what's important that you learn, what's important is that you learn how to learn a language quickly. You understand how programming languages in general work in general. You learn how to learn, and you learn how to pick up things quickly. That's what's most important. And that when you're learning different languages in college or school or in a course, it's very important that you just figure out, okay, this is different. How is it different? What are some things I can do to make it easier? What have I already learned that I can reapply here? So to answer your question, while I've used Java, I learned C++ and C in college. I use Python, I've used SQL. The answer is, based on what you want to really go into, the language will change. If you're going to visualization, then learning R and Python is definitely going to help you. If you're going into front end, then learning JavaScript and having a basic understanding of HTML, style, CSS, looking into different kinds of JavaScripts like React, Angular, or maybe in React, and maybe looking into Ruby on Rails for backend stuff. So depending on what you're interested in, the language changes, and I might not be able to give you a straightforward answer.
So you mentioned documentation. Is there like a general rule of thumb that you would follow when, like, to know are your docs like thorough enough or more, or I don't know if less would really be applicable, but.
So documentation is something that you can just do automatically. Remember when I mentioned the multi-line commenting? So the multi-line commenting is going to help you with documentation. Any of the stuff I mentioned, Sphinx, Doxygen, Java Docs, they look at those multi-line comments. They look for that @param, @return, or @arg identifiers to figure out, okay, which one's a variable, which one's a parameter, what's expected for return. And there'll be a kind of a styling thing. So when you do those multi-line comments, you might have to make 1 or 2 edits, and then you can just run these functions to create documentation for you. You don't have to be really thorough. And I would say if you're able to write down multi-line comments for functions, classes, and files, maybe, depending on your situation, but mainly classes and functions, you should be fine. And by doing that, you're going to help yourself double time. This is the part where you're going to understand a lot more of how it affects you. I know I've talked a lot about these code hygienes, these best practices, and all of this is really difficult to maintain every single time. You're not going to be the only programmer out there who hasn't done all this, who doesn't do this consistently, who might start this for about a week and then forget to do it. You'll be one of the many. But what's going to make you distinct from any other programmer is that you follow these, because by doing comments, by taking time to design, by working on making sure you have a nomenclature, making your code more readable by having unit tests, having people review your code if you're in a team, reformatting code. By doing all this, you are by default going to become a better programmer. I'm not asking you to follow off all of these off the bat. Pick one to three things. You can choose commenting, and you can even break it into, I want to do single line comments and I want to do multi-line comments to start off with. Sounds good. Start with that. No one's asking you to do more. Once you get that and it becomes a second nature to do that as you're typing, as you're programming, as you're working on a project, then be like, maybe I should also work on structuring them and splitting them into meaningful. When I say meaningful, I mean meaningful functions, not just random functions, meaningful classes, not just random classes. So as you go, build the difficulty by adding them in and just work on it as you're coding. If you skip a comment, go back and add it in. Make sure it's an active learning process. As you're typing, you are implementing it, you are learning. And then it'll become second nature. For example, so we have like different kinds of companies. You have an entry-level startup, you would have a medium-sized startup, you would have like an advanced, like a big startup. Usually those become companies and big tech. For example, a real example of a medium-sized startup is that they have different languages that they use, but based on the language, they change how well they maintain their code hygiene. For JavaScript, they only do comments. For Java APIs, because those need to be well documented, they have Java docs. And if there's any product API or architecture that needs to be flushed out and has to make sense for anyone else coming on board to the project, they have documentation. But you can see right then and there that they might not have class level commenting. They might not have function level commenting. They might only just have line level commenting for JavaScript, and that's totally fine. This is what you're going to face when you start working. When you're working with these kind of scenarios, I would strongly still suggest you practice that. You have your functions you have your comments for your functions. You have your file level commenting. Still practice that. Unless there's something that your company doesn't follow and it's required for you to not put those comments, that's a different matter. And yes, it might take a couple more minutes, or it might take 15 more minutes after you're done coding to review and make sure everything is good. But this is going to make sure that you code fast even in the future, right? If you don't have comments now and you start programming, if you don't have code hygiene now, you start programming, at the end of the day, a year later, when you're working with the same piece of code, like it was mentioned early on, you're going to have difficulty. You're going to slow down your programming efficiency. And you want to maintain that. You want to increase your efficiency. And that's where readability, structuring, flow, all this comes into play. And for this medium-sized startup, there isn't much effort. It is expected for each and every programmer to have clean and readable code. It's expected that there's a reviewer for every single merge. You, by default, any company that you go to you will have a reviewer for the code you're about to merge in the main master code. You will have versioning. That's another way to have maintain code hygiene. Is if something goes wild and maybe you screw up or another person messes up with a bug that they've introduced, then you just revert it. They will use linters. At least this company does use the industry level JavaScript ESLint. They also don't use it for Java and other stuff. Languages wise, like I mentioned, they use Java, Scala, C++, Python, JavaScript. Given that they have comments, they have documentation, they're putting in some effort. What do you think? What's the level of importance for code hygiene here?
I think it's very important, probably at the topmost of priorities, because as you mentioned before, if you look at the same code in the future, it could take hours more just to understand what you did before so you can improve it.
Yeah, And that's what this company is trying to do on a very minimal level. Like it's having enough documentation, enough coding, enough commenting, enough code hygiene, such that it's it's part of the culture. And when they are looking back at it later, it's a lot more clear. Now for a big tech, it's a lot more intense. There's internal style guides. You have to follow them for each and every single code sample you submit. It might be something specific to your team if you want to modify one or two things, but in general, it should follow the style guide. And the amount of effort, like I mentioned, for every code merge, you're going to have to follow the style guide. There's going to be a reviewer who's going to criticize your code, advise and make sure everything looks good, follows a convention. And there's an internal custom linter as well. You run the linter before you submit the code, for review. Otherwise, it's going to come back automatically and say, hey, yeah, no, there's a linter issue. Fix that before you send it to your reviewer. This is supposed to decrease the reviewing time and make sure your code piece merges into the master code really quickly. And for languages, usually big tech, based on what they're working on, they use different languages. So you name it, we have it. Now, Facebook is an example of big tech. They have auto formatters built in, so it formats the code for them. It's indents accordingly. It has it makes sure that it's blocked up accordingly. There's a space before each function, two lines before every class, maybe, and then documentation. While it's not there, it's improving. And this is kind of like the reason why might be because of the old model they used to have. Because they're building fast and they might not have done too much documentation, but definitely a lot more of the documentation comes from their test-driven documentation. They make sure they have tests for every piece of code they write. So that way, if you don't understand what the code does, they go to the tests and then you can say, oh, okay, this does this, this. Just by looking at what the inputs are and the outputs are. And the effort is, there's a team dedicated to ensuring code hygiene and best practices, but it's also similar to other companies where you have a reviewer for the code merge. You're expected to have some sort of code hygiene or clean code when you submit it, just because a reviewer is going to be taking a look at it. And there isn't any specific linting. Maybe personally for like certain projects, there might not be linting, but certain groups might be using third-party or custom linting. That's more internal. I'm not privy to that details, but languages-wise, you guys most likely have seen Facebook languages online. There's React.js, there's Hack, C, C++, Objective-C, Swift, Java, Python, you name it. Like I said, big tech, you name it, we have it. So those are some examples of how companies do it. And the solution is to continuously keep your code as clean and simple as it can be and never let the rot get started. So rather than feeling the pain of going back in your code and code with the intention of making sense to a person with basic knowledge of coding. Make it clean, make it readable, make it traversable.
So I know you mentioned peer review. So I was just wondering, for example, if me or the interns, any of us have, say, like individual or personal projects we're working on, but we still want to get an outsider's perspective in case for some reason we plan to show it off to others. Do you know if like on GitHub or any resources basically where you can get that code review done?
So code review, actually, you can do it with your friends also. I'm sure every programmer has a programmer friend. If you don't, you'll find one soon. They are the best resource. You can have GitHub, and I do highly suggest, if you don't have a GitHub, get a GitHub. Get used to sending code from reviews, and you can just add them into the GitHub repo so that you get the practice. Get used to version control. Get used to working with different branches, workspaces, all that stuff, because that's going to be very important. And like I said, you can have your friends or people that you know who've worked in the tech field just go through the code and give their 2 cents on it. A good way to get really involved in this whole process is there are a bunch of open source softwares. There's a lot of open source projects, softwares, and code where you can get started. You can find something small, maybe a feature or a bug that has to be fixed. because there'll be a list of features they want to build as well as issues they have. Just go and try to tackle it. You'll learn a lot more about how things work by doing that. You will have peer reviews because someone's always going to peer review your merges when you merge into the master code. You'll have discussion forums. For example, if let's say someone has a bug and they report it, you can go in and discuss with people saying, I think the issue is this, let me try this. Nope, it wasn't this. This was, I think it might be this. And then you go back and forth. Maybe you have a solution just working on it. You ping the forum. So that's one way to get real life peer reviewing from strangers that you don't know. And that way you'll get an outside perspective of how things work, or like how reviews are done as well. So GitHub, go, you'll find linters, you'll find open source code, you'll find your future. GitHub, the place to be.
So when you were in like high school, early college, etc., did your expectations for what you'd be doing in college and your career, etc., line up then with what you're actually doing now?
No. It changes over time. When I was in high school, I had a 60-year retirement plan. I had a 60-year retirement plan. I was intent on doing my MBA 2 years after my college. I was planning on double majoring. And, you know, by the time I hit my 30s, I would be like a millionaire. Yeah, I had a lot of plans. But that aside, I wanted to specifically be a person who was working with both hardware and software. I went into college with for my computer science and engineering degree. So I still took hardware courses. I still had courses on filters, electrical like analysis, and circuit analysis, sorry. And then I also worked with embedded systems. But when I came out of college, I realized that, yes, I like working with hardware, but I want to be more software. So I found a job, an opportunity. And in my job, we work with everything. My team is engineering productivity team. So we work with a bunch of different teams. And every few months, I'm changing projects. Maybe it might be the same thing I've done in the past, except more advanced, more defined. Maybe it's another aspect of the same thing I've worked on, or it's a completely new thing. And over the past almost 2 years, I've worked with different languages, different teams, different products. This wasn't what I was expecting when I came out of college, let alone when I went into college, but I've had the opportunity to explore things. And that's something you should definitely keep in mind, is keep your mind open, keep an open mind. When you're going into college, absorb as much as you can. You find something interesting, give it a shot. Maybe it's a course you want to try. You're not really sure you want to take the full commitment, then go in for the first lecture. If there's something that you want to do in the future, let's say in your third year in college, go and sit into the class without even like signing in or signing up for the class. Just go get that exposure and you'll realize whether or not that's something you like. And so, yeah, keep an open mind, go and explore, and you're definitely not going to end up doing exactly what you want, and it might take time for you to get there. But at the end of the day, you'll be content at where you are as long as you're always trying to keep an open mind and searching for the next best thing for you. My only advice for you guys is don't be the programmer who wrote the old dreaded code. Whenever I have discussions with my friends, I've had phrases such as pre-2009 code, pre-2012 code. Oh, it's the code running, like it's so old that there's no comments. Dude, I'm in charge of the project where I have to clean up all this stuff. Don't be the reason for that. Write clean code, practice code hygiene, pick a couple of best practices, work on that as you're programming. It's the same thing with typing. You don't get better at typing by selecting each and every single key. You get it by trying to enforce the motion as you're typing. If you do a different motion, you go back, rewrite it with the right motion. So practice that. Do it slow. Thank you.
Yeah, thank you so much. So, Nishant graduated recently, currently works at Google, so he has a ton of experience under his belt, especially with software engineering and code hygiene in general. He was really nice. Thank you once again coming here and, educating us all about code hygiene. I'm sure not just the interns. I know me personally, I have like a lot I learned from just this 1 hour. So I guess just a final question that I was curious about. So do you see any, with this COVID and just how quick the world's adapting to, you know, different situations. Do you see a big change coming in, you know, like coding or coding hygiene even in the near future?
Yeah, coding hygiene is definitely going to be more important, especially when people are working remotely. When you're in person, it's a lot more easier to go over and ask someone a question about, hey, how does this work? But given that people are virtually working and you're like working from home and they have virtual meetings and everything, it's going to be a lot more important to have code hygiene. It's going to be a lot more important to have readable code so that it reduces the amount of effort. A lot of companies have seen productivity downtimes as well as uptimes. And right now, a lot of people are working a lot more often. And during this time, rather than programming quick and programming fast, programming clean is going to ensure that there's a consistent productivity level or productive nature in the future. In terms of changes due to COVID-19, not specific to code hygiene, definitely there is a lot of opportunity. Think about it. Now, since we're virtual, a lot of the in-person in-person experiences now have to become virtual. That's how new businesses are going to come up. You're going to have more businesses which are directed towards the virtual experience, stuff you can do from home, products you can use at home, ways you can grow and learn at home. As a programmer, as a budding programmer, amateur programmer, whatever you want to call yourself, as an experienced, if you want to say you're an experienced programmer, even I don't call myself an experienced programmer after 2 years, let alone my dad who's almost retiring. But if you want to call yourself that, feel free. I hope you're making the next product. But try exploring some ideas. If you think there's something you want to program that might help, go for it. Make it clean, make it efficient, make it nice, or just get the prototype out. This is the time to try something new, and maybe it'll stick, and that'll be the future, your future. Maybe that's one thing you didn't expect either.
Well, thank you so much for coming, and thank you for being here and sharing your expertise. I am sure that the interns have taken a lot away from it. So thank you once again. And with that, we are now closing today's In Talent informational session. So excited to see you all at the next one.